Morning, this is Mr. Keaton. I'm here to talk about special cases in right triangles. There's two special cases that we're going to talk about. One is a isosceles right triangle. That means two sides of the same length. In this case, it's x and x. And isosceles right triangles will always have angles opposite each other that are 45 degrees. And so these triangles are always going to be in the proportion of 1, 1, radical 2, where radical 2 times whatever the other side is your longest leg or your hypotenuse. So in this example one over here, we have an isosceles right triangle. This is also 45 degrees because they sum to 180. Therefore, this leg on the left here will be the same, so that's 12. And because they're in the same proportions of 1, 1, radical 2, this is going to be 12 radical 2. And they're that straightforward. Down here, example B, the two legs are 10 radical 2 and 10 radical 2. So remember, this is x times radical 2, so this is going to be 10 radical 2 times radical 2, and that gives us radical 2 times radical 2 is 2, also known as 20. So sometimes when there's radicals thrown in, they can be made to be a little more confusing, but otherwise it's no big deal. So up here, remember, if this is a right triangle and these are 45-degree angles, then the proportions of 1, 1, radical 2 apply, so we have x, x, and x radical 2. So we can solve for x fairly easy by dividing both sides by radical 2, which gives us x is equal to 15 over radical 2. 15 over radical 2. And we should rationalize the denominator by multiplying top and bottom by radical 2 over radical 2, which gives us 15 radical 2 over 2. Is the length of those two legs. Going on to the next special case, we have a 30, 60, 90 triangle. And they will always have the proportions of 1, 2, radical 3. 1, 2, radical 3. Remember that 2 is larger than radical 3. If you punch that in your calculator, you're going to get like 1.5 something. So 2 has to be the hypotenuse. That can be tricky to remember. So in this, the longest leg is opposite the biggest angle. So 6, this is the longest, and this is the shortest. Longest and shortest. And then the hypotenuse. So in this problem down here, we have 100 for the hypotenuse. So the short leg is going to be half that because it's 1, 2, 1, 2. So that'll be equal to 50. And then the longest leg is going to be the shortest side times radical 3. So it's going to be 50 radical 3. 1, 2, radical 3 are the proportions. So down here we have the shortest leg, and the hypotenuse is double that, because that's two sides, so that's going to be 68. And then the long leg is going to be the shortest leg times radical 3, 34 radical 3. And that's all there is to the two special case triangles. Let's look at a few examples with them. Continuing. So in this final leg, so this is a 45, that's a isosceles right triangle, so these are 45 degrees. So this must be equal to 15. And this side's 15 radical 2. Over here we have the same thing. This is 18, this side must be 18, and therefore the hypotenuse, because it's an isosceles right triangle, is 18 radical 2, and we can bubble in D. Moving on to the next one. 1, 2, radical 3. It's a 30, 60, 90 triangle. So the proportions. So Alex said, oh, me. I have a team logo patch. This must be for hockey in the shape of an equilateral triangle, which means all these angles are 60 degrees. And 60 degrees. Well, the sides are 2.5, so we have 2.5 inches on each side. And we can go ahead, what is the approximate height? So let's go ahead and draw that height in. Here it is. And all of a sudden we created two triangles. This is a 30-degree angle, because that one's 60 and we have a 90 there. Therefore we have a 30, 60, 90 triangle. And this bottom length, if the whole side's 2.5, must be 1 1/4 inches. So 1 1/4, twice that is